Hi, welcome to BC Video 12.2 Part 1, Differentiation of Vector-Valued Functions. So, on page 4, we're in section 12.2, page 842, and again we're going to do differentiation and integration. So first of all, they start off with the actual, what they call the definition of the derivative of a vector valued function. It's the limit definition. If you remember when we first introduced derivatives last year, we had f prime of x as the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So it's really the same exact thing, only instead of the real valued function f, we have the vector valued function r. Instead of the independent variable being x, the independent variable is t, and therefore instead of delta x we have delta t, instead of x plus delta x we have t plus delta t, instead of f we have r, etc. R is differentiable at c if r prime of c exists, which means if the derivative from the right equals the derivative from the left. This is all the same stuff that we did for real valued functions. So here's the shortcut rather than doing the whole limit definition. If r of t is f of ti plus g of tj, then very simply r prime of t is f prime of ti plus g prime of tj. You will leave the I and the j separate. You'll only be doing this to the coefficients of I and j, which are real valued functions. If it's in component form, again, the derivative means you'll just take the derivative of each component. So in 1 through 8, it asks you to sketch the plane curve represented by the vector valued function and sketch the vectors r of t0 and r prime of t0 for the given value of t0. Position the vectors so that the initial point of r of t0 is at the origin, normal. But they want you to do the tip-to-tail method, which is that they want you to take the initial point of r prime of t0 to be at the terminal point of r of t0. And then they want to ask you what's the relationship between r prime of t0 and the curve. Okay, so this is something like number 10. Numbers 1 through 10. So here's the given function. The purple is what they'll give you. They'll give you a vector valued function. In this case, they give it to you in terms of I and j. Personally, I'd rewrite it in component form. And they're giving you the value of t0 to be 1. So the question is, first to sketch a graph. So to sketch a graph, basically you're going to take this original vector valued function and really look at it as a set of parametric equations. So you'll have x equals t, y equals t cubed. So if t is equal to x, then we can replace this t by x. We get y equals x cubed. And of course, x is t and y is t cubed. That means x and y can be any real numbers. There's no restriction. So you get this curve right here. Now they do want you to sketch the vector r of t0. t0 is 1. So if I take my r function and I replace all the t's by 1, I'll get 1i plus 1j, which is the vector 1, 1. So they asked you to place that vector so that the initial point of r of t0 is at the origin, and then I'm going to go to a terminal point of 1, 1. Then they also want us to find r prime of t0 and sketch it. So r prime of t, if we take the component form, derivative of t is 1, derivative of t cubed is 3t squared. Replacing those t's by 1, we get the point 1, we get the vector 1, 3. Now here's the deal. They want you to attach the initial point of r prime to the terminal point of r of t0. So here's our terminal point. We're going to put our initial point here, and then I'm going to move right 1 and up 3. So you have to realize if we started at the point 1, 1, and I move right 1 and up 3, I'll be at the point 2, 4. That does not mean the components of this new vector are 2, 4. You would have to slide it back in, but that's not the question. Now, what you will realize is that this vector right here, the derivative vector, is actually tangent to the red curve at that point, the terminal point of r of 1. Okay? Which kind of makes sense because it is a derivative. Okay, in 11 through 22, they just want you to find the derivative. I'm going to rewrite this as 4t to the half. This is t squared times t to the half, which is t to the 5 halves. At this point, you have a choice. You can either keep the k part and just do it with the k part or forget the k part. Either way, we're not doing 3D. Okay, so that'll be 2 times t to the negative half. Don't forget times I. Derivative of t to the 5th is 5 halves, t to the 3 halves times j. And then since this was given in radical form, I'm writing these in radical form. And then you could put it back in component form if you want. Number 20, r of t is arc sine t, comma, arc cosine t. So the derivative is the derivative of sine t, which is 1 over square root 1 minus t squared. Derivative of arc cos of t is simply the negative of the same thing. In 23 through 30, they want the first derivative, the second derivative, and the dot product of the first and second derivatives. So here's number 30, e to the negative t squared, r prime of t, the derivative b to the negative t is e to the negative t times negative 1. Derivative of t squared is 2t. So that's part A. Part B is find the second derivative. So we differentiate again with respect to t. We're going to have negative e to the negative t times negative 1, which will make it positive e to the negative t. Derivative of 2t is 2. The last thing they want us to do is to take these two answers and do a dot product with them. So it's the product of the x components plus the product of the y components. And you will end up with the following. Okay, the properties of derivatives. Let r and u be differentiable vector-valued functions of t. Let w be a differentiable real-valued function of t, so it's not a vector function. And let c be a scalar. So you can imagine that if you took the derivative of a constant times something, just like we did before, we will pull that constant on the outside, and then we'll have c, the constant, times the derivative of r of t, which is r prime of t. Just like before, if you have the derivative of sum or difference, you can split it up. Here you have a real valued function times a vector valued function. Basically, you have the product rule. You have first factor times derivative of second factor plus second factor times derivative of first factor. This is again, the derivative of the dot product. You'll notice this isn't not a dot product because that's a scalar times a vector, but this is the dot product of two vectors. You'll notice again, it's the product rule. First factor times derivative of second factor plus second factor times derivative of first factor. Do not worry about number 5. You're not responsible for it. This one here is just the chain rule. Remember when it used to be d dx of f of g of x, it would be f prime of g of x times g prime of x. And here, if this is just for them later to help prove a theorem, that if r of t times r of t is equal to c, which is a constant, then r of t times r prime of t equals 0. Don't worry about that theorem either. But certainly do not worry about this one. That's something you will learn in science class, but you're not responsible for it here. Okay, in 43 through 44, use the properties of the derivative to find the following. Now, this is your call. They're telling you to use the properties of the derivative. You don't have to. So they're giving you r of t, u of t. Notice I'm just ignoring the k parts. So they're giving you r and u. The first question is, what is r prime of t? So derivative of t is 1. Don't forget the I. Derivative of 2 sine t is 2 cos t. Don't forget the j. As you can tell, I am at school and it's 3:05. The bell just rang. Then they want the second derivative. The second derivative, of course, you'll just take the derivative of the first derivative. Pretty easy. That's going to be negative 2 sine t j. And then they want the derivative of the dot product of r of t and u of t. So you can do either find the dot product and then take the derivative, or you can use the fact that it's a product and you can do a product rule on that. But either way, you'll get the same answer. Okay, so here's the product rule. Here's actually taking the two vectors. Here's r. So you take t times r prime of t. Oh, u of t. So it's r times u. So it's t times 1 over t plus 2 sine t times 2 sine t. That'll give you the derivative of 1, which is 0, plus the derivative of 4 sine squared t, which is 8 sine t cos t. Or as we said, you could actually just do a product rule on here and then take your r of t dot product with u prime of t plus u of t times dot product of r prime of t. You'll get the same answer. Question D is what is the derivative of 3 times vector r minus vector u? You can simply pull that 3 on the outside, and that'll be 3 times the derivative of vector r minus the derivative of vector u. E I crossed out because it was one of those cross products you're not responsible for. This asks you for the derivative of the magnitude of vector r. So vector r was t comma 2 sine t, so the magnitude is the square root of t squared plus 2 sine t squared. And then you'll take the derivative of that expression, which I'm not going to bother doing. Here they ask you to use the limit of definition of the derivative to find r prime of t. They mean they want you to actually use the limit definition, not just the definition.